All right, good morning. This is activity 32 from our Unit 5 review. It's our last review. And actually, I know some people this is going to be a review for, some people this is going to be brand new. And for my kids, it's going to be kind of a mix of both. Because we did cover solving with square roots, we did not get to completing the square. So we're kind of in the middle. Okay, so if you remember last time I told you there were 5 solving methods, and we did graphing and factoring in the last video. So we have our last 3 solving methods in this video. We have square roots, we have completing the square, and we have the quadratic formula. So we're going to start with square roots first because it is the easiest, but it cannot always be used. Okay? So square roots can only be used if there is only one x term. So if you remember in the last video, we would have something like x squared plus 2x plus 3 or something that we had to solve, and we could factor it, but we couldn't use square roots on those because there were multiple x terms. When we get to section 2, completing the square does use some square roots, but not in the same way that we're going to use it here. And we couldn't just take the square root of each side of the equation on these because we have multiple x terms. Okay, so for square roots, there's a few different ways you can approach this. But the basic structure that we want to do is we want to have x squared equals some number, and we want to take the square root of each side. Or we have x plus or minus something squared equals a number, and we want to take the square root of each side. So we need it set up to look like one of these two things. We either need x squared equals or a binomial squared equals. So we need it set up in one of 2 ways. Okay, so let's start with this one. We want to get x squared by itself first. So we're going to add 6 to each side. We're going to treat this like a linear equation up until the point where we take the square root. We end up with 3x squared equals 6. We're going to divide both sides by 3. And we get x squared equals 2. Now we don't want to know what x squared is. We just want what x equals. So we're going to take the square root of each side. These cancel. And we get x equals. I'll leave some space and put square root 2. Now when you think about taking the square roots have 2 solutions. Up to this point, we've only ever used the positive square root, but there's also a negative square root. So think about it. If you take the square root of 4, well, we all know that's 2, because 2 times 2 equals 4. But negative 2 times negative 2 equals 4. So the square root of 4 could also be negative 2. So we use a symbol to recognize this. What we're going to say is x equals positive or negative square root 2. So if you remember, when we look for solutions to quadratics, we're looking for the x-intercepts. And most quadratics have 2 x-intercepts. You could have none, like it could sit above or below the line and not cross it. You could have 1 where the vertex touches the x-axis, but a lot of times you're going to have 2 solutions. So we have x equals plus or minus the square root of 2, or positive square root 2 and negative square root 2. This symbol is how mathematicians get away with not writing x equals square root 2 and x equals negative square root 2. That symbol is a shortcut and lets you be lazy. Okay, So let's look at the next one. So this is set up like a binomial, like we had here. So because we have x plus 2 in parentheses, we just have something squared equals 66. So what we're going to do is we're going to go ahead and take the square root of each side. So what I have is the squared and square root cancel. And I have x plus 2 equals plus or minus the square root of 66. So again, I want to get x by itself. So I'm going to subtract 2 from each side. And this gives me x equals negative 2 plus or minus the square root of 66. And we can just leave it there. Yeah. So this is not too terrible. I'm just going to have a side note here. You could get the decimal answer. It really depends on what your teacher wants. I usually, with my kids, like it left as a radical, but if for some reason you needed the decimal answer, what you would do, I'm going to do this on my phone real quick. If you did not know, you can do square roots in your phone. You just have to turn your calculator or your phone sideways. So we're going to do 66, take the square root of it. We get 8.124. So what I could do is I could do negative 2 plus 8.124 and negative 2 minus 8.124. And this is going to give me 6.124 and negative 10.124. And then you would have 2 decimal answers. So you could go either way with this. You could have your decimal, or you could yeah, that's right. Okay, I just had to double check that one. I'm like, I got a little confused. I overthought. Okay, so I typically like this because it's a lot nicer and neater and prettier. But if your teacher wants the decimal answer, convert this into decimal and then do negative 2 plus and negative 2 minus. Okay, so C. Let's see. We have half of x squared minus 30 equals 10. So again, treat this like a linear equation. Let's add 30 to each side first. And I have half of x squared equals 40. So then what I want to do is to get rid of this fraction, we're going to multiply both sides by 2. And that gives me x squared equals 80. Take your square root. X equals positive or negative square root 80. So just as a recap, this is 2 separate solutions. You could write this as x equals the square root of 80 and x equals negative square root 80. Or you can write it as 1, which is what I typically do. Alright, let's move on to number 2. Okay, so we have something called completing the square. And this should be equal 0 real quick. We've got that on there. Okay, so completing the square is an EOC or LEAP 2025 favorite question. I will be the first to admit, when I did this as a student, it did not make sense to me. As an adult, I kind of like this method because it's kind of nerdy, but as a kid, I really struggled with this one. So I'm going to try to explain where it comes from to the best of my abilities. So if you remember in the second square root, we had x plus 2 squared equals some number. And we were able to take the square root of that whole binomial. And then we were just left with x plus 2 equals something. Or plus or minus something. So this is what we're trying to get to. We're trying to get to a binomial squared. Okay. So, if we think about that, let's see what that actually looks like. So if I take a binomial and square, and we're going to use a plus b because we want to, I'm trying to think of how I want to say this. I don't want to use numbers or anything because then it doesn't really prove it. I just want you to see what kind of happens with letters. So we're going to take a plus b and square it. So that does not mean a squared plus b squared. These two things are not equal. These are not the same thing. Every time that you see this and you do this, a puppy dies. So, we don't want to do that. We're doing a plus b times a plus b. We're squaring a plus b. We're not squaring a and b. Okay, a times a is a squared. A times b is either ab or ba, however you want to write it. A times b is ab or ba, and then b times b is b squared. So what this ends up equaling is a squared plus, we have two of these, so 2ab. Now I'm running out of room. So this ends up equaling a squared plus 2ab plus b squared. Okay, so whenever we square a binomial, we have two things squared, and then the middle term is those two numbers together multiplied by 2. Okay, so when we complete the square, we have, what ends up happening is we have a squared and this 2ab. And we have to figure out this number. So remember, we're not going to have it laid out this pretty. We don't know what b is. So how would I get b? Well, you would take this number and divide it by 2a. Okay, the 2a's would cancel and you're left with b. Then you square it to get your b squared. Okay, I know that doesn't really seem to make a lot of sense right now, but that's what we're going to do. So when we complete the square, we're going to leave our a squared term alone. We're going to take whatever is here, divide it by 2, and then square it. Okay, I'm going to leave this page, or this little sticky, I'm going to leave it over here so we can kind of reference it. Okay, so we have these set equal to 0 so far, and that's good, but the good thing about completing the square is it doesn't always stay equal to 0. This is something you can do when this doesn't equal 0, which is nice. Okay, so right now this is not something we can factor. So what we're going to do, and this is why it's called completing the square, we're going to move c over. So we're going to add 6 to each side. And that's going to leave us with x squared plus 10x. We're going to put plus, and we're going to leave a box there, equals 6. Now if I add something to the left of my equation, I also have to add it to the right. Okay? So now I'm going to complete the square so that I can factor this. So remember what I said. We're going to divide both sides by 2a. So 10 divided by 2, and then my a value, or whatever's here, this is x squared. So remember, this is a squared, right? So if I take the square root of that, that would just be x. So we're going to divide by 2x. 10x divided by 2x is 5. And if I square that, that becomes 25. So what I have now is x squared plus 10x plus 25 equals, and then 6 plus 25 is 31. Okay, so I know that seemed kind of weird. Again, we divided this by 2 and a to get our 5, and then we squared it, and now what we can do is we can factor this. Okay? What can I multiply to get 25? Well, I can multiply 5 and 5, and that gives me 10. Also, the whole point of completing the square was to make this factorable. We wanted to make it to where we could do a plus b squared. Well, what was my a? X. What's my b? 5. Remember, we got our b here. So what we have is x plus 5 squared equals 31. So I know this seems so super weird. I told y'all this was something that I was very confused with as a kid. Okay, so what we're going to do now is we're going to solve it like a regular equation. And we're going to practice the completing the square part on these two. So we're going to solve it like a regular equation. We're going to take the square root of each side. The square and square root cancel, and I'm left with x plus 5 equals positive and negative square root 31. Okay, I'm going to move this. So it's taking up a lot of room. Okay, so then to get x by itself, we're going to subtract 5 from each side. And x equals negative 5 plus or minus square root of 31. And that's it. So it's weird. It's not super difficult, but it is a little weird. Okay, so let's try B. We want to move our C value over because right now this is not factorable. So when we move this over, we're going to add 14 to each side. X squared minus 4x. We're going to put plus and a square, so we remember to complete it, equals 14. And remember, if I add a square on this side, got to add a square on the other side. Okay, so let's remember our completing the square. To fill this box, we're going to divide it by 2x, or 2, that's our a value. Divided by 2x. What we get is negative 4 divided by 2 is 2. Negative 2 squared is positive 4. So I have to add 4 to each side. So my new equation is x squared minus 4x. We leave that 4x alone, okay? That dividing is just to get this number. So we didn't change this. We're figuring out what to put here. So x squared minus 4x plus 4 equals, I'm going to add these, 18. Okay, so this is set up to where I can factor it. We're going to have a, and then my b is negative 2, so here. So we have x minus 2 squared equals this 18. So the completing the square, yeah, it's weird, but it makes your problem easy. Again, I recommend only doing this if you have an even number here. If you have an odd number, then you're going to have a fraction, and then you have to square a fraction, and it's not fun. So I recommend only doing this if you have an even number for b. Alright, take the square root of each side. Squared and square root cancel. You have x minus 2 equals plus or minus the square root of 18. We're going to add 2 to each side. X equals 2 plus or minus the square root of 18. Alright, last one. Okay, so this is weird because we have this 4x on the opposite side. So we want to combine this 4x and this 4x. So I'm going to subtract 4x from each side. I have 0 equals x squared minus 8x minus 32. Just seeing if I can. Okay, you still can't factor. I had to think about it for a minute. Yeah, cannot factor. Right. Yeah, cannot factor. No, cannot factor. Had to think about it. Okay. So, remember, we're going to do just like we did last time. We're going to add 32 to each side. And we don't want to forget to complete our square, so we're going to have square plus 32 equals x squared minus 8x, and we're going to put our square here as well. Alright, to complete our square, divide by 2x. X is cancel. Negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. Alright, so I have 16 plus 32, that is 48. 48 equals x squared minus 8x plus 16. So now I can factor that. We have, I'm going to swap sides. We're going to have x minus, because this was negative, my b value was negative 4, so x minus 4 squared equals 48. Okay? X minus 4 squared equals 48. Take the square root. We have x minus 4 equals the square, plus or minus the square root of 48. Add 4 to each side. X equals 4 plus or minus the square root of 48. Okay, so if you notice when we do these problems, we're getting irrational solutions. We're getting things that have imperfect squares. That's why we can't use factoring. Factoring is for when we have perfect, well, not even perfect squares, but when we have perfect, pretty rational factors. So we can't use factoring here. If you wanted to graph, you could graph these, but where is square root of 31 on your graph? That's going to be a pain in the butt to look for. So these are nice, pretty simplified looking answers, but they're not rational. So that's why these other methods are so, like the easier methods aren't going to work here because those work for rational numbers. Okay, so we covered square roots, which was really simple. We covered completing the square, which was not as simple, but like it makes some sense, but it's not really, I mean, it's a little weird. I'm going to be upfront and honest about that. It's a weird concept. It's not hard, but it's weird. I would recommend practicing this because when you get to geometry, you're going to need to know how to complete the square when you work with circles. You're not going to have to take the EOC this year, but if you were taking the EOC, this is like their favorite thing to ask about. And it's just a good thing to know. And then we get into the quadratic formula, which is not difficult. It's really easy to use. It's plug in, simplify. And it works for every single quadratic equation. The only issue is it does take forever to do. It's not a bad thing, but it just does. So you can solve every quadratic formula or quadratic equation with this function or formula, sorry. But sometimes the other methods are a little bit quicker. So there's that. Okay, so quadratic formula. Remember, standard form of a quadratic is ax squared plus bx plus c. So when you see your quadratic function, you take the coefficient of x squared, put in for a everywhere. Take the coefficient of x, put in for b. Take the constant, put in for c. And then you just do math and simplify. So the first thing I would do for all of these is double check that it's written in standard form. Like if we look at A, it's not. So we're going to subtract 6x from each side and get x squared plus 3, x squared minus 6x plus 3 equals 0. I would also make sure that I've got equal, like that all my equations are equal to 0 and not some other number. Alright, so let's go ahead and get started. So, first thing I would do is identify my A, my B, and my C. So we have x squared with nothing in front of it, so that means my A is 1. In front of x is negative 6, so that's my B. My constant is positive 3, so that's my C. Okay. So then we just start plugging into here. So we have x equals, so this is the quadratic formula. I don't know who came up with it. It was someone who is much smarter than I am. But, so this is your quadratic formula. You can use it to solve any quadratic equation. Alright, so we get x equals negative b. B is negative 6. Plus or minus the square root of b squared. Again, b is negative 6. Minus 4 times a times c. Okay, a is 1. C is 3. And all of this is over 2 times A. And A is 1. Okay, I'm just going to double check. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay. So then we just start simplifying. I go from left to right. And just simplifying pieces as I can. Alright, so first thing I see is negative, negative. Well, negative and negative is positive. So this is going to be positive 6. Plus my square root of negative 6 squared. 6 times 6 is 36. Okay, minus 4 times 1 is 12. No, I'm sorry, 4 times 1 is 4 times 3 is 12. Just thinking too fast. Over 2 times 1 is 2. So I have 6 plus or minus the square root of 36 minus 12 is 24 over 2. Okay. So we can do one of two things. We can leave this here. And that's two separate solutions. You have 6 plus square root of 24 divided by 2, and 6 minus square root of 24 over 2. So we can leave this here. If you have been taught how to take the square root, or how to simplify an irrational root, you could take it a little bit further and do that. I know my kiddos, we did not really spend a whole lot of time on simplifying roots because that's not one of our standards. So I'm okay. I am comfortable with it being left here. You could divide the 6 by the 2 and have this as 3 plus or minus square root of 24 over 2. You cannot divide the 24 by 2 because that 2 is not in a square root. If this were in a square root, then I could. So you could simplify it either way. I have a feeling you would see this more than you would see this. But they're both correct. Okay, so I'm going to draw a line because it's kind of bleeding into territory. This is already in standard form. So A is 2, B is 8, C is negative 3. And then I'm just going to plug into the quadratic formula. So x equals negative b, so b is 8, plus or minus the square root of b squared. B is 8, so 8 squared minus 4 times a is 2, c is negative 3, over 2 times a, and a is 2. Alright, so we'll just start simplifying. X equals, we have negative 8, so we'll just write that as negative 8, plus or minus the square root of 8 squared is 64. Negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24. Okay, and then 2 times 2 is 4. Alright, so we have x equals, we're going to simplify a little bit more, negative 8 plus or minus the square root of 64 plus 24 is 88, and that is over 4. Okay? And if I want to simplify that, I can. Negative 8 divided by 4 is negative 2, plus or minus square root 88 over 4. And again, we can simplify this root, I believe, but again, that's kind of an Algebra 2 skill. If you'd like a video on that, I don't mind making one, but for right now, we're just going to leave it as is. Okay, the last one. I'm trying to get it. Here we go. Okay, last one. 3x squared minus 5x plus 1 equals 0. A is 3. B is negative 5. C is 1. Plug into our quadratic formula. X equals negative b, and b is negative 5, plus or minus the square root of b squared, so it's negative 5, minus 4 times a times c. See, a is 3, c is 1. And that's all over 2 times a, and a is 3. Alright. And then we start simplifying. So negative negative 5 is positive 5. Negative 5 squared is 25. 4 times 3 is 12, times 1 is 12, and it should be negative. And all of that is over 2 times 3 is 6. Okay, 25 minus 12 is 13. So this is 5 plus or minus the square root of 13 over 6. And this does not simplify, so you can leave this as is. You could, if you really, really wanted to, put this in the calculator. So you would do 5 plus square root 13 divided by 6. And let's see, what does that give us? Okay. We're going to do 5 plus square root 13 is 8.6 blah 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 divided by 6. 1.434. Oops. And then we'll also do x equals 5 minus square root 13 over 6. Oh, yeah, that's right. That would be 0.232. But you can see why graphing this would not be very fun, because those are not some fun solutions. Okay. Alright, last thing. Oh, second to last thing. Okay. Next thing we want to go over is the discriminant. The discriminant, so in our quadratic formula, this piece that is inside the radical is called the discriminant. And if we look at just the discriminant, we can tell how many solutions this equation is going to have. If the discriminant is greater than 0, it's going to have 2 real solutions. It's going to cross the x-axis twice. And that makes sense, because when we take the square root, we have a positive and a negative number, so that gives us 2 solutions. If it equals 0, it has 1 solution, and that's because if we take the square root of 0, square root of 0 is 0. It only has 1 square root. It doesn't have, you don't do positive and negative 0. That doesn't make sense. So you just have square root 0. So you get 1 solution. So, but if it's less than 0, if you get a negative number, if your discriminant is negative, what ends up happening, so let's say if you were trying to take the square root of negative 4. Well, how do you get negative 4? I can't do negative 2 times negative 2 because that gives me positive 4. And I can't do positive 2 times positive 2 because that gives me positive 4. The only way to get negative 4 is to do negative 2 times positive 2. But that is not a square root because the square root is something times itself. And negative 2 and positive 2 are not the same number. So there's no real solution. Now, if you want a quick Algebra 2 lesson, you get into imaginary solutions, because mathematicians still had to take square roots of negatives, even though it doesn't exist. In order to solve other problems, they had to come up with some sort of solution for this. So what they said is, oh, it's an imaginary solution. The solution would be 2 times I. And I stands for imaginary number. So it would be the square root and then I for it being imaginary. So there you go. I taught you something. So, but for right now, because this is negative, we would just say no real solution. And it wouldn't have x-intercepts at all. So what we're going to do is we're going to use the discriminant first and figure out how many solutions, and then we'll come back, and if there are solutions, we'll solve the equation. So our discriminant is just the b squared minus 4ac. So a is 1, b is 2, c is negative 8. So our discriminant is b squared minus 4ac. So we are doing 2 squared minus 4 times 1 times negative 8. So 2 squared is 4. Negative 4 times 1 is negative 4. Negative 4 times negative 8 is positive 32. And 4 plus 32 is 36. So because this is a positive number, we're going to have 2 solutions, 2 real solutions. Okay, then it says solve the equation. So we've already figured out the discriminant for the quadratic formula, so we can just kind of fill it in. So x equals negative b is 2, plus or minus the square root of, well, we already found b squared minus 4ac. That's 36. So the square root of 36 over 2 times, well, what's a? A is 1. So this becomes negative 2 plus or minus the square root of 36 is 6 over 2. Okay? Now we can actually come up with pretty solutions for this. I'm excited. So we get negative 2 plus 6 divided by 2. Well, negative 2 plus 6 is 4. And 4 divided by 2 is 2. Then we also have negative 2 minus 6 over 2, which is negative 8 over 2, which is negative 4. So our two solutions are x equals 2 and x equals negative 4. Okay. All right. Let's look at B. All right, same concept. Let's go ahead and identify our A, B, and C. A is 1, B is 2, C is 5. Okay. So, we'll check our discriminant first. Okay. So, B is 2. We have 2 squared minus 4 times A is 1 times C is 5. 2 squared is 4 minus 4 times 1 is 4 times 5 is 20. And 4 minus 20 is negative 16. Okay. So our discriminant is negative, which means there is no real solution. Okay. So there's no point in continuing and solving because this is negative, so there's not going to be a solution. Alright, so let's go on to C. A is 1, B is 2, C is 1. We're going to check the discriminant. B squared. So we got 2 squared minus 4 times 1 times 1. Okay, 2 squared is 4 minus 4 times 1 is 4 times 1 is 4. So we get 4 minus 4 equals 0. So it's equal to 0. That means we have one solution. So we're going to go ahead right up here. One real solution. Okay. Alright, so let's figure out what that one real solution is. So we're going to finish our quadratic formula. X equals negative B is 2 plus or minus the square root of the discriminant is 0 over 2 times A, which is 1. So this is negative 2 plus or minus 0. So square root of 0 is 0 over 2. Okay, well 2 plus 0, or I'm sorry, negative 2 plus 0 is negative 2. Negative 2 minus 0 is negative 2. So we end up with just negative 2 over 2, which reduces to negative 1. So my final answer is x equals negative 1. So what this means is that x equals negative 1, that's not only my x-intercept, that's also my vertex. If you only have one solution, that solution is your vertex. Alright, D. Okay, I have A is 1, B is negative 4, C is positive 4. So we'll do our discriminant. We have negative 4 squared minus 4 times 1 times positive 4. So negative 4 squared is positive 16 minus 4 times 1 is 4 times 4 is 16. So we get 16 minus 16, which is 0. So again, one real solution. Okay, and let's figure out what that one solution is. So we're going to go back to our quadratic formula. X equals negative B plus or minus the square root of, our discriminant is 0, all over 2a. Okay. Negative, negative is positive, so this is positive 4. Okay, we know the square root of 0 is 0, and adding and subtracting 0 does nothing. So we can kind of just cross that out. 2 times 1 is 2. 4 over 2 is 2. So my final answer is x equals 2. And again, that is both the solution and the vertex. Okay. Whew, lengthy video. Sorry about that. I know that's 2 lengthy videos in a row. But we're almost done with quadratics. So, yay! The only thing we have after this is like modeling with quadratics and real world quadratics, which we can kind of use Desmos for and won't take nearly as long. Okay. Number 5, write each quadratic function in vertex form and then analyze the function by identifying the direction of the opening, vertex, minimum, maximum, and number of x-intercepts. Alright, so we want to go from vertex form, or from standard form to vertex form. Okay, so in order to do that, we have to complete the square to go from here to here. Okay, so we're going back to completing the square. So what we're going to do is I'm going to move this 13 over. Okay, so we have, and we're going to change this y to 0. So this becomes negative 13 equals x squared minus 6x. And remember, we want to complete the square, so we're going to add our square to each side. Okay? Alright, so how do I fill that square in? Well, remember, we divide by 2 and x. The x's cancel. Negative 6 divided by 2 is negative 3. Square it is positive 9. Okay, so we're going to go ahead and add 9 plus negative 13. It's going to be negative 4 equals x squared minus 6x plus 9. Okay, and then remember, the whole point of completing the square is to make this factorable. So this becomes negative 4 equals x minus 3, we take that b, minus 3 squared. Okay, now if you look at vertex form, we should have a k on this side, and we should have y equals. So what I'm going to do is I'm going to take this 4, let me rewrite what I have. And I'm going to add it to each side. And that gives me y equals x minus 3 squared plus 4. Okay. So now we have it in vertex form. Alright, so let's look. It wants to know which way is it opening. Well, this is positive, so it opens up. Okay. And then let's look at our vertex. Since it's in vertex form, if we look, h is the x coordinate of the vertex, k is the y coordinate. So my h is 3, and my y, or my k, is 4, so my vertex is 3/4. So if I were to graph this, my vertex would be at 3, 4, and it opens up. So is this going to have any x-intercepts? No intercepts. So there's no solutions. So no intercepts. And then, what's the other thing it looks for? And minimum or maximum. So it opens up, so it has a minimum. And remember, your minimum is the y-coordinate of the vertex. That's your lowest point. So my minimum is 4. So the good thing about vertex form is it's really easy to analyze your function and know what it looks like without even graphing it. Or doing a quick graph like that. So yeah, so that's fun. Okay. Let's look at B. So I hope completing the square is getting a little easier. We're going to do the same thing. We're going to move this 8 over. We're going to change the y to 0. And so what we end up having is we end up with, trying to figure this out. We're going to have our box plus 8 equals negative x squared minus 6x plus our box. Okay. So let's look at that real quick. We have a negative in front of x squared. So what I'm going to do is, I'm actually going to change this. We're going to leave it as plus 8 equals. I'm going to factor out this negative. And we're going to have x squared plus 6x. And we're still going to have plus our box. We're not going to change our box because our box should always be positive. And now let's complete the square. So we're going to divide by 2x. That gives us 3. 3 squared is 9, so we're going to add 9 to both sides. Give me just a second. Okay, so this box should always be positive. But because we have this negative on the outside, basically I could distribute that negative. That would make this a minus 9. So we're going to make this a minus 9 over here. I had to double check my math real quick before, because it was starting to throw me. So we're going to make this 9 negative. So we have negative 9 plus 8. And negative 9 plus 8 is negative 1. And this equals negative x squared. Oops, let's rewrite this over here. Negative 1 equals negative x squared plus 6x plus 3 squared. Not plus 3, plus 9. I was looking at this 3 plus 9. Okay. And this isn't squared yet. I'm jumping ahead of myself. Okay, so then we want to factor this so that it does have that squared. So this will be negative 1 equals negative x plus 3 squared. Let's add this 1 to each side, and this becomes y equals negative x plus 3 squared plus 1. And I double checked in Desmos. That's correct. So here's my new equation. So let's look at this. This has a negative out front. So it opens down. Let's write this in blue. Opens down. Okay, my vertex. We have positive 3, which remember, our h up here is negative. So we're going to take the opposite sign. So my vertex is going to be negative 3. My k is 1. So if I were to graph this, I'm going to go back to this graph. My vertex is at negative 3, positive 1, and we said it opens down. So that means it's going to have 2 solutions, 2 intercepts, and it's not going to have a minimum because it opens down. It's going to have a maximum. It's still that y coordinate of the vertex though, and my maximum is 1. Okay, and then that should be it for this lesson. So I know it's like an hour long. Thank you so much for paying attention. I hope you felt free to take breaks every so often and maybe like work a section of the guided practice and independent practice or something. But thank you for paying attention for a whole hour. Like, that's really awesome. If you have any questions, feel free to email your teacher. If I'm not your teacher, feel free to drop a comment drop a comment in YouTube, and if I see it, I'll answer it. But yeah, make sure you email your teacher. We've had a couple of people emailing whoever's recording the video, and they're like, I don't know who you are. So make sure that you email your teacher first. But if you have a quick question that maybe I can answer, you can drop it in the comments and I'll try to answer it. So yeah, so hopefully this was helpful. I know this was a lot of information. If you have any questions, let us know. And I hope you guys have a good day. Stay safe. Bye.